Chapter 6: Physical and Chemical Changes. Lesson Preview. Physical changes. Chemical changes. Rusting of iron. How to prevent rusting. Characteristics of chemical changes. Types of chemical reactions. Crystallization. You must have seen a number of changes taking place around you all the time. Setting curd from milk, spoilage of milk, water freezing into ice, a bud blossoming into a flower, an ice cream melting into liquid all represent a change. Make a list of changes which you observe around you. All the changes which take place in our surroundings can be classified into two kinds: physical changes and chemical changes. Physical changes. Let us have a look at some of the changes taking place around us with the help of some simple activities. Activity. Take some ice in a plate. Keep it in the sun for some time. It will start melting. Keep the mixture of ice and water back in the freezer. What do you observe? Water again converts into ice. Activity. Take a square piece of paper. Draw 4 circles on it. Cut the circles along their outlines. Now place them on the table and try to join the pieces to get back the original piece of paper. You will obviously notice that you cannot join all the pieces of paper to get back the original piece of paper, but the property of each piece of paper does not change. Activity. Take a wooden stick. Break it into smaller pieces. Try putting pieces together to make a stick. Is it possible? The original stick could not be built from the pieces. There is, however, no change in the property of wood. Activity. Take some water in a pan. Boil it. After some time, you will see steam rising up. Now, hold a cold plate at a little distance above the steam. What do you see? You will see tiny droplets of water on the plate. Activity. Take a beaker with a little water in it. Dissolve 2 tablespoons of salt in it. Heat the solution over a burner. What do you observe after some time? You will see that slowly the water evaporates, and salt is left behind. In the above activities, you saw the change in size, activity 1, 3, and the change in state, activity 2, 4 and 5. Properties such as size, shape, color, physical state, temperature, etc. are called physical properties. When a substance undergoes a change in its physical properties only, that change is said to be a physical change. Characteristics of a physical change. Only physical properties of a substance undergo change. Physical changes are generally reversible. No new substance is formed. A very small amount of energy is either absorbed or evolved during a physical change. Chemical changes. When 2 or more substances react in such a way that there is the formation of 1 or more new substances, the change is called a chemical change. The reacting substances are called reactants, while the new substances formed as a result of the reaction are called products. Characteristics of a chemical change. New substances with different properties are formed. Chemical change is irreversible. A large amount of heat is either evolved or absorbed during a chemical change. Burning of paper, spoilage of food, germination of seed, curdling of milk, ripening of fruits, burning of gas, bursting of crackers, digestion of food, burning of candle are all examples of chemical changes. A chemical change is also called a chemical reaction. Activity. To prepare magnesium hydroxide in the laboratory. Note, to be performed under the strict supervision of a teacher. Take a small piece of magnesium ribbon, clean its tips with sandpaper. With the help of a tongue, hold it over a candle flame. What do you observe? It will burn with a brilliant white light, leaving behind a powdery ash. The ash is not like the ribbon. We can represent the change by the following equation. Magnesium, Mg, plus oxygen, O2, magnesium oxide, Mgo. Mix the ash with a little water in a beaker, stir it well. Test its chemical nature with the help of a blue and red litmus paper. The red litmus paper turns blue. The blue litmus paper remains the same. What do you infer from this? Is aqueous solution acidic or basic? Magnesium oxide dissolves in water to form magnesium hydroxide. Mg plus H2O MgO2. Magnesium hydroxide, as you have already learned in the previous chapter, is a base. So you have seen that two new substances are formed: magnesium oxide, ash, on burning of magnesium ribbon, and magnesium hydroxide by mixing the ash in water. Caution: do not stare at the burning ribbon for long. It is dangerous. Activity: to show displacement reaction between copper and iron. Note: to be demonstrated by the teacher. Take 100 ml water in a beaker. Dissolve 1 teaspoon of copper sulfate in it. Add a few drops of dilute sulfuric acid to it. You will get a blue-colored solution. Divide the solution into 2 beakers. Drop an iron nail into 1 beaker. Wait for half an hour. Compare the color of the solution in the 2 beakers. Do you see any change in the color of the solution in either of the beakers? You will notice that the color of the solution changes from blue to green due to the formation of iron sulfate, a new substance. A brown-colored layer is also seen on the iron nail. The chemical reaction is written as copper sulfate plus iron sulfate plus copper. QSO4 plus FePSO4 plus Cu blue. Gray, green, brown. Thus, in all the above activities, we have seen new substances are being formed. They are all examples of chemical changes. Some activities involve both chemical and physical changes. In a burning candle, both the processes take place simultaneously: melting of wax and burning of wick. Chemical changes may show the following signs. A fizz, gas, is produced. Sound may be produced. A new smell may be produced. When food gets spoiled, a foul smell is produced. Heat or light may be produced. When crackers are burned, heat, light, sound and unpleasant gases are produced. A change in color may take place. Activity: take a brinjal, a potato, and an apple. Cut them into half and keep aside for half an hour. Do you see any change in color? This color change is due to the formation of a new substance on reaction of chemicals present in these things with air. Rusting of iron. You must have seen that if an iron object is left outside in the open, a reddish-brown layer is deposited on its surface. This is due to the presence of rust, which forms naturally due to a chemical reaction. The process of the formation of rust is called rusting. Iron plus oxygen plus water iron oxide. Rust. From air. 4 Fe plus 3 O2 plus 2 H2O2 Fe 2O3 middle dot H2O. From the above equation, it is seen that both oxygen and water are necessary for the formation of rust. The layer of rust falls off slowly and fresh metal surface is exposed to further rusting. This gradually weakens the iron object. Damage due to rusting causes huge monetary loss, as iron is used to make bridges, ships, cars, trucks and many other articles. Therefore, rusting needs to be prevented. Rusting is particularly destructive to the shipping industry, as ships are always in contact with salt water and the air over the seas is also humid. Salt speeds up the process of rusting. How to prevent rusting? We can prevent rusting by preventing iron articles from coming in contact with air or water or both. Some commonly used methods to prevent rusting are: applying a coat of grease or paint on the object on a regular basis. By galvanization, it is the process of depositing a layer of zinc on an iron object. Zinc forms a layer of zinc oxide on reaction with air and thus forms a barrier between iron and the atmosphere. Galvanized iron sheets are used for roofing. The iron water pipes we use in our homes to carry water are also galvanized. Similarly, a coating of chromium or nickel on iron objects also prevents rusting. By alloying, Certain metals can be made rust-free when mixed with other metals and non-metals. Stainless steel is an alloy of iron, nickel, chromium, carbon, and manganese. It does not rust. Characteristics of chemical reactions. A chemical reaction has one or more characteristics. Some of these characteristics are as following. Evolution of a gas. If one of the reactants is in solution form, then a gas may evolve during a chemical reaction. Evolution of gas is confirmed by appearance of effervescence, bubbling, in the liquid. In a chemical equation, the evolution of a gas is shown by putting an arrow pointing upwards. CaCO3, calcium carbonate, plus 2HCl, hydrochloric acid, CaCl2, calcium chloride, plus H2O, hydrogen, plus CO2, carbon dioxide. Zn, zinc, plus H2SO4, sulfuric acid, ZnSO4, zinc sulfate, plus H2, hydrogen. 2nano3, sodium nitrate, 2nano2, sodium nitrite, plus O2, oxygen. Change of color. One of the products formed during a chemical reaction may have a different color than that of the reactants. CaCO3, copper carbonate, green, copper oxide, black, plus CO2, carbon dioxide. Formation of precipitate. When two chemicals in solution form react, and an insoluble substance is formed, it settles down as a precipitate. The formation of a precipitate in a chemical reaction is shown by an arrow pointing downwards. FeCl3, iron chloride, plus 3NH4O, ammonium hydroxide. FeO3, iron hydroxide, plus 3NH4Cl, ammonium chloride. CuSO4, copper sulfate, plus H2S, hydrogen sulfide, Cus, copper sulfide, plus H2SO4, sulfuric acid. Changes in energy. Almost all reactions are accompanied by energy changes. During the reaction, energy may be released or absorbed. Accordingly, there are two types of chemical reactions. 1. Exothermic reactions. Reactions accompanied with release of heat are called exothermic reactions. Release of heat is shown by writing plus heat on right-hand side of the equation. CaO4, calcium oxide, quicklime, plus H2O, water, CaO, calcium hydroxide, slaked lime, plus heat. 2 endothermic reactions. Reactions accompanied with absorption of heat are called endothermic reactions. Absorption of heat is shown by writing dash heat on right-hand side or plus heat on the left-hand side of the equation. N2, nitrogen, plus O2, oxygen. 2No, iron hydroxide, heat. Energy in other forms such as light and sound is also evolved in some reactions, as in the explosion of firecrackers. Change of state. In some chemical reactions, there is a change in physical state of the reactants and the products. To show the change of state, S for solid, I for liquid, G for gas, and AC for aqueous are written after the symbols or formulae of the reactants and the products. When an electric current is passed through water, in which a little sulfuric acid has been added, it gives hydrogen and oxygen gases. 2H2O, water, 2H2G, hydrogen, plus O2G, oxygen. Types of chemical reactions. There are different types of chemical reactions. Some important types of chemical reactions are mentioned below. 1. Combination reaction. When a compound is formed from its elements, or from simpler substances, the reaction is called combination reaction. A plus B ab. Magnesium reacts with oxygen on heating to form magnesium oxide. 2Mg, magnesium, plus O2, oxygen, 2Mgo, magnesium oxide. Nitrogen reacts with hydrogen to form ammonia. N2 nitrogen plus 3H2 hydrogen 2NH3 ammonia. 2. Decomposition reaction. Decomposition reaction is one in which a compound breaks up into two or more substances. Decomposition is normally caused by heating or by passing electricity through it. A barrow A plus B. When calcium hydroxide is heated, calcium oxide and steam are produced. Ca-O2. Calcium hydroxide, Ca, calcium oxide, plus H2O, water, steam. When an electric current is passed through water in which a little sulfuric acid has been added, then the water decomposes to give hydrogen and oxygen gases. 2H2O, 1, 2H2, G, arrow, hydrogen, O2, G, arrow, oxygen. 3. Single displacement reaction. In this type of reaction, one element replaces another element from a compound. It is found that, in general, a more reactive element replaces a less reactive element from its compound. A plus, BC, AC plus B. Iron is a more reactive element than copper. If a piece of iron is added to a solution of copper sulfate, iron sulfate is formed. Copper metal gets deposited on the iron piece. QSO4, copper sulfate, plus, Fe, iron, PeSO4, iron sulfate, plus, Cu, copper. 4. Double displacement reaction. In a double displacement reaction, two compounds react by exchanging their elements or groups. A plus CD plus CB. These reactions are of two types. A. Precipitation reactions. In these reactions, two compounds react in their aqueous solution state to form an insoluble product as a precipitate. Aqueous sodium chloride and silver nitrate react to form a white precipitate of silver chloride. NaCl, sodium chloride, plus AgNO3, silver nitrate, AgCl, silver chloride, white PPT, plus NaNO3, sodium nitrate, B. Neutralization reactions. In these reactions, an acid reacts with a base to form salt and water. Ha acid plus BOH base, up salt plus H2O water, H2SO4, sulfuric acid, plus 2NaV, sodium hydroxide, Na2SO4, sodium sulfate, plus 2H2O water, HCl, hydrochloric acid, plus co-potassium hydroxide, KCl potassium chloride plus H2O water. 5. Oxidation and reduction reactions. Oxidation, addition of oxygen or removal of hydrogen from a substance is called oxidation. The substance which gives oxygen or which removes hydrogen is called oxidizing agent. C. Carbon, plus O2, oxygen, oxidized, CO. Carbon dioxide. H2S, hydrogen sulfide, plus Cl2, chlorine, oxidized, S sulfur, plus 2HCl hydrogen chloride. In the first reaction, oxygen is the oxidizing agent, as it supplies oxygen to carbon. In the second reaction, chlorine is the oxidizing agent as it removes hydrogen from hydrogen sulfide. Reduction, addition of hydrogen or removal of oxygen from a substance is called reduction. A reducing agent can reduce other substances by removing oxygen from them or by supplying hydrogen to them. H2 hydrogen, plus QO, copper oxide, black, reduced, Cu copper, reddish brown, plus H2O water, Cl2 chlorine reduced plus H2S hydrogen, S sulfur reduced, plus 2HCl, hydrogen chloride. In the first reaction, hydrogen is the reducing agent as it removes oxygen from copper oxide. In the second reaction, H2S is the reducing agent as it supplies hydrogen to chlorine. Crystallization. Crystallization is a process by which pure crystals of a substance are obtained from an impure substance. Crystals are the purest form of a substance having a fixed geometrical shape.